Hey scholars, it's Miss Marnon, so I'm going to help you guys with some more mixed proportional relationships review. We're still doing it by standard, so today we're going to do RP2B, which is finding the constant in proportionality, and 2C, which is about writing proportional equations. So our objective today is to have all of those skills we need to do that. So here's our DIN. It says circle all that represent a proportional relationship. So pause the video and circle any of these different representations that are proportional. Okay, so the first one I'm going to do is a graph because that's pretty easy to see. We're looking for a straight line through the origin. So this is a straight line through the origin. This one is not. The next easiest one is proportional equations. So we're looking for y equals kx, where it's k times x. We don't want adding, subtracting, dividing, we just want multiplication. So right here, this one is proportional, this one is not. For our tables, it's a couple more steps. We have to divide every y by every x and see if we get the same number. If we get the same number, it's proportional. So 6 divided by 2 is 3. 18 divided by 3 is 6. Since I already have different numbers, I know that this is not proportional. For this other table, we have 1 divided by 5. That's going to be 1/5. Or 0.2. 8 divided by 40 is 1/5 or 0.2. And then 13 divided by 65 is also 0.2. So this is our proportional graph or table. So for our preview question, we have find the constant in proportionality for each of the proportional relationships you circled. So I'm going to do that in a different color. I'll come through and write that in orange next to each of these. So easiest one might be this equation. Whatever that k number is, that is what it is. So for this one, k is 50. For our table, we already figured it out. We did all the y's by x's. That's how we get our k. So we got 0.2 or 1/5. For this graph, we just need to pick a point and divide it out. So this point, oh, my thing keeps jumping on me. So I see that we have the point 2, 3. And my pen's not lining up right or erasing when I'm telling it to erase, but that's just kind of the way of the world sometimes. So here we have 2, 3. If you divide the y, which is 3 by 2, you're going to get 1.5. It's one of the most common ones we see is 3 divided by 2, 1.5. So now let's work on 7 RP2B. So I can identify the constant of proportionality, or you can call it K, or you can call it the unit rate. It's the same number, no matter what it gets called. And so that's broken down into a couple different things. So from a table, from a graph, from an equation, and from a description. So we can find the constant of proportionality from a table by, take a minute, see if you can fill this in. So pause the video, fill in this first exercise question. Okay, so we already talked about this. We can divide y by x. So now it wants us to find the constant of proportionality for each table. And also just cross off this row right here. I meant to cut that out, but I did not. So all you're going to do, these are already proportional relationships. We've done these. We decided they were proportional in a previous lesson. So now all we need to do is pick one row, do y divided by x. So here, we're going to do y divided by x. Here's our x, here's our y. We can do 26 divided by 2. And we're going to get 13. So it's going to be 13 apples per tree. For this one, here's our x, here's our y. Doesn't matter which one you pick, I'll just do the first one. We'll do 3 divided by 2, and we get 1.5. Oops, sorry, my pen is still being crazy. So we get 1.5, and that's going to be dollars per ticket. So we can just throw in a $sign per ticket. Okay, so why don't you do these next two on your own? So these two will be practice. So this is what Miss Marnon and Miss Eastman will be checking that you did on your own in your page, in your OneNote. So the two I just highlighted, you're going to do on your own. So if you need time to do that right now, you can pause the video. So exercise 2, I can find the constant of proportionality from a graph by. So pause the video. How do you find the constant of proportionality from a graph? Okay, so you should have written down by now that you pick a point. I don't have my normal tablet, so my pen's being crazy today. Our points are x comma y. Then divide y by x. So for this first one right here, I'm going to pick this point. So this is 5, 15. So this is my x, this is my y. So I just need to do 15 divided by 5. And we get that the unit rate, or the constant proportionality, is 3. And this is gallons per minute. Speed of a sloth, we've done this one a couple of times. This one you should start remembering seeing. I'm going to use this point. This point is 1.5, comma 9. So we're going to do 9 divided by 1.5. We type that in our calculator, and you'll end up getting 6 feet per minute. The next two, these are the ones that you're going to do independently for practice. So this is what I'm going to check. This is what Miss Eastman's going to check. So the moon and the earth weight and the hiking distance is what you're going to do on your own. If you want to do those right now, you can pause the video and get those done now. Okay, so next we have exercise 3. I can find the constant of proportionality from an equation by. This one's easy. If we have an equation, y equals kx, it's there. It's just that number in front of the x, or whatever variables we're using. We don't always use y and x. We've had a bunch of practices where it's different variables, but whatever variable it is, it's the number multiplied by it. So I'll do these first two with you. All this one is, this is 4. The second one, that number that's multiplied, it's 2. So on your own, do these next two. So you can pause the video if you need to do those next two. Okay, exercise 4, I can find the constant of proportionality from a description by. This is just going to be calculating the unit rate, like if you were doing a unit rate problem. So I'm just going to write calculate unit rate. So Miss Marnon is baking cookies. For each cup of flour, she uses 3/4 cups of sugar. So for each cup, that's 1 cup, 3/4 cups of sugar. So we can do 3/4 sugar divided by 1 cup flour. And that's it right there. It's 3/4 divided by 1. It's just 3/4 cups of sugar per cup of flour. Miss Eastman reads 140 pages in 7 days. So we want pages per day, not days per page. So we're going to do pages per day. So 140 pages divided by 7 days, we get 20 pages per day. These next two you can do on your own, and they're also good practice for that 7RP1 standard, calculating unit rate. So if you want to, you can pause the video and do those on your own right now. Okay, 7RP2C is writing and using proportional equations. So you need to find K, which we just did in the standard before, and then you just need to put it into the equation. And you also need to be able to do that when you don't have a Y and an X if they give you different variables. So luckily on all of these, they are going to give you a Y and an X. So write an equation in the form Y equals KX for each table or graph shown below. So if I was going to find K for this first table about the cost of eggs, I would do X divided or Y divided by X. We can do 9 divided by 6 and you get 1.5. So if I was going to substitute this into the equation Y equals KX, it would just be Y equals 1.5X. So that's it. You're going to be able to do this next table on your own. For this next graph, we need to find what that K is. So you're going to need to pick a point. So I'm going to pick this point, 12, 2. We need to do Y divided by X. So our K is going to be 2 divided by 12, which is actually going to give us 1/6. It is a decimal, but I think 1/6 is easier to write out than that long decimal. So we just need to substitute this K value into our equation Y equals KX, or we can just say Y equals 1/6 X. So there are 2 examples, and you can do the other table and the other graph on your own. Here we have 2 descriptions. Mr. Nasser is training for a marathon. He runs 3 miles in 24 minutes. Write an equation that shows how many miles D Mr. Nasser runs for each minute T. So this one we do have different variables that are not Y and X. We have a D and a T. So we need to figure out if we want minutes per mile or miles per minute. Normally we kind of like the time to be the second one, but if you think about how many miles you can run in a minute, it's not even a full mile. So for this one, we're going to want minutes per mile. So how many minutes it takes to run each mile. So if I'm going to set this up, oops, I need to write K. So we need to find our minutes per mile. So we would normally do Y divided by X, but in this case, we're going to do minutes, which is T, per mile, which is D. So writing it like this is going to help me keep it straight for which variable goes where when I write the equation. So if I'm going to do 24 minutes divided by 3 miles, we're going to get 8 miles per minute. So our K is 8. Normally we write Y equals KX, but for this one, instead of Y, I'm going to have T. I know my K is 8, and instead of X, I'm going to write D. So there we go. There's our equation. You can do this one on your own about Miss Figueroa mixing paint. So you can pause the video and do that now. Okay, for our next question, it says, how many miles can Mr. Nasser run in 35 minutes? So you can substitute this value in for 35. Now here's what's going to happen though. This is for T for time. I do 35 equals 8D, right? Because we didn't get rid of the D, it's still there. The distance, the miles. That's what we need to figure out. In 6th grade, you guys learned how to solve one-step equations that look like this by dividing on both sides by 8. If that's not what you want to do, that means we're going to need to write an equation for the other way around where we can flip the D and the T. We've done an example about this. It was the question about Devin filling a water tank from a faucet. We can flip it if we flip that K value. So if instead we did 3 over 24 and we got 1/8, then we would switch where the T and the D are in our equation. So instead of starting with T, we could write D equals 1/8 times T. So because we flipped that unit rate, we can flip those variables around. So this equation might not have worked out nicely for us. Maybe we forgot how to solve those. We're going to work on solving equations in our Unit 5 and Unit 6. But for now, if we need to, we can write a different equation that will also work. So this also represents the proportional relationship. So instead, we can substitute that T, that 35, and then all you need to do is multiply 1/8 times 35. And I'm not going to tell you what that is because I want you to practice typing on your calculator with the fractions because some of us are still having issues with that. So you're going to practice writing that and you're going to tell us what the answer is for how many miles Mr. Nasser can run in 35 minutes. And then you're going to also answer this question using the equation that you wrote above. So how much yellow paint will Miss Figueroa need if she uses 10 gallons of blue paint? So you're going to be able to do that one on your own. So once you've finished all of the problems that I highlighted in this video, you're going to work on this exit ticket. Make sure that if it tells you that you're going to do it based on, so let's highlight, it says based on the number of pounds, this is going to be your X. When you see something like this, so W is going to be like your X, and then P is going to be like your Y. So when you're reading this, to make sure you're dividing in the right order and writing the variables in the right place, you can make sure you're doing that. When you're all done with this lesson, make sure you're checking Canvas, seeing if there's any extra work. If you feel like you've got a better handle on these standards, you can go and take the standard quizzes for 7RP2B and 7RP2C. Make sure you're clicking Mark as Done in Canvas for your own organization, and have a wonderful rest of your day.